I have another LCD TV sitting here in my workshop, but unlike most of my TV videos, this is not going to be about a repair. What I'm going to be doing with this particular TV is recycling the screen, the power supply, and the backlight inverter, and making this into a dedicated VGA monitor. Some of you might recognize this TV actually. It used to be in my living room, and I had shown it in one or two of my old home theater PC videos. This was a trash pick TV, and we used it for a number of years. However, the main board has always been very troublesome and very annoying because it would run for a given amount of time and lock up and make very loud noises out the speakers, and you couldn't turn it off by the remote or the buttons. You had to pull the power cord for a second and then plug it back in and start over. And I worked on the main board a couple times but never did manage to solve the problem. I'm pretty sure it's one of the VGA chips on the board that's bad, and I'm not willing to spend a couple $100s on another board for this TV. It's only a 720p model anyways. But I always did like the screen in this TV. It's got a rather nice LG panel in it with 500 nits brightness and 178 degree viewing angle. I believe it's a super IPS screen. I'll have to look at the spec sheet again. But I think this will make a perfect candidate for a monitor conversion. So let me put this thing up on the bench and get the back panel off. Here's the new control board I'm going to be using. As you can see, it's very tiny in comparison to a typical LCD main board. This is one of those little universal control boards that you can get on eBay very easily for less than $10 including shipping. And I got this one right from a seller in China, but there are some US resellers that carry boards like this. And I like these particular boards because of their jumpers. Most LCD controllers have to be programmed through a special programmer that uses the VGA connector, and the firmware has to be set up for a specific panel type. These boards have a little chart on the back where you pick the panel resolution and the number of LVDS channels with this block of jumpers here. And then this jumper here is the supply voltage for the panel, which can be 3.3, 5, or 12 volts. It's basically a one-chip solution. It's got the main chip over here with its supporting EEPROM, the clock crystal, and a couple voltage regulators. That's all you really need to drive an LCD when you don't have a tuner, an HDMI, and audio, and all those extra goodies. So let me start taking this TV apart, and along the way I'll be talking about how to pick the proper cabling and set everything up for something like this. Here's a look inside the TV now that I've got the back panel removed. This particular model is a Vizio VX42L HD TV 10A, built in about 2007. And as you can see, there's not much in here, which is typical of LCD TVs. They don't need the massive power supplies and sustain boards that plasma TVs usually have in them. So it's just a smaller power supply and the control board, backlight inverter setup, the T-Con board, and of course the panel itself and the speakers. And the only thing I'm going to be removing from this is the control board, some of its associated wiring like the AV jacks and the original button board, which all the switches are worn out anyways, and I'm not going to need the speakers obviously. And when you're working with a panel that's this big, most panels over maybe 19 or 20 inches, most of them I've worked with, the backlight inverter is considered part of the LCD assembly. So when you find the data sheet for the LCD panel, it's also going to have the specs and pinouts for the inverter modules. And you might notice this particular TV has two inverters. That's called a master-slave setup. Basically, they're nearly identical boards. The only difference is only one of them has the additional input pins for some of the control signals, like the inverter on signal and the backlight brightness control. You can see the ribbon cable that comes out of the master inverter here and feeds the slave inverter with its control lines. But as complicated as these might look, they're actually quite simple. There's only a lot of wires because they parallel lots of them due to the amount of current that's used to run these. And most of these larger panels operate the inverters at 24 volts DC. So you'll have, like, for example, 4 ground wires, 4 24 volt wires, and then, you know, a couple of control wires. You know, usually there's one wire for the brightness signal, one wire for the power on signal, and, you know, and that's pretty much all you need to run a backlight inverter. The power, the on-off signal, and the brightness signal. I'm assuming this is the diagnostic output connector, which I won't be using. That actually sends signals back to the control board to notify it if the inverter's not operating properly, and the TV will shut down. But for what I'm going to be doing with this, the only thing I need is the power, the brightness, and the on-off signal. Now, anyway, enough rambling about the inverters. I've got to take this out of here, make some room to work, and I'm going to talk about how to wire up this power supply to work standalone without being controlled by the original board, and also how to make sure you have the proper cabling and controller setup to run your particular panel. Here's a look at the original main board from the TV. A couple of years back I had actually gone through and replaced a couple of voltage regulators up here that were known to fail on this particular model, but it didn't fix this TV, and I didn't feel like putting in more effort into it, so out with the old and in with the new. I thought it was kind of interesting how this main chip here is an ARM. I wonder if it's the same ARM that makes the CPUs for cell phones and stuff. You can see that it looks like they had originally planned on putting a heatsink on here, but never did. And I wouldn't be surprised if this chip gets really hot and just went bad, or the solder went bad. But, who cares? Again, look at the enormous difference in controller size. You know, it's amazing how small the board can be when you don't need all the additional circuitry that a typical TV has in it. Probably the most important step in doing any custom LCD work is having the data sheet on hand for whatever panel you're working with. This particular panel is made by LG, and the model number is LC420WX7. I've got the spec sheet up here, and the reason this is so important is because even though the same physical connector is used on many different panels, the pinout and operating voltage can vary quite a bit. And as you can see, this particular panel is 12 volts. It's got 4 power pins, 4 ground pins, and then the rest of the control signals. There are lots of panels out there that have the same physical connector, but will have the power pins on the opposite end, and, you know, things in a different order. And, you know, if you take a control board that's designed to run a panel like this, that's 12 volts and has this certain pinout, and you hook it up to a smaller screen that, say, is meant for 5 volts and has the 5 volt pins down here and the ground pins right here, you know, obviously you're going to burn something up most of the time. So it's really important to know the voltage and pinout of your particular screen. As for the physical connector, this particular screen uses the JAE connector, the FIX30 pin. And JAE is Japan Aviation Electronics, and, you know, they're probably the biggest manufacturer of those particular connectors, but there are some clones, which is why it says or equivalent. I'll talk more about the connectors in a little bit. Now, the next page talks about the inverter pinout. You know, and like I was saying, they parallel several of the wires, which is why there's so many coming out of it. 5 wires for the plus 24 volts, 5 wires for the ground. You have 1 wire for the analog dimming, 1 wire for the on-off signal, another wire for the, it says burst dimming. I believe that's another word for PWM dimming signal. I think you pick one or the other depending on what type of control board you're using. And the last pin is the status output, which is what I was talking about, that signals the main board to the operating status of the inverter. I'm not going to be using that with this particular project. And down here in the notes, they talk about the operating voltages, and how to use each of the signals. For example, the on-off signal, 0 volts would turn the inverter off, and 5 volts would turn it on. And for the dimming, 0 volts would give you the dimmest picture, and 3.3 volts would be the brightest. And it says if you leave the pin disconnected, it will typically go to 1.65 volts. And you can make the backlight even brighter by going up to 3.3 volts, but it does decrease the life of the lamps. So whether or not I'm going to be using the inverter at full power in the finished project, I'm not entirely sure. But this is why the spec sheet is so important, because there are so many variations on the pinouts and voltages, even with the physical connectors being the same. One thing that's frustrating with this TV is that the LVDS connector is down here in a tight spot, and this piece of metal that's in the way is part of this large backplate that holds the power supply. And I could take that off, but then I'm going to lose the VESA mounts, and I'm going to have to remount the power supply directly on the back of the panel itself. So it's going to be a little bit difficult to get down in there and swap out that LVDS connector. Well, as you can see, I got frustrated and took that backing plate off so I could access that connector easier, and that helped a lot. Here's a look at the original cable and the cable that I'm going to be using. And unfortunately, this is not the correct cable. I have to order the proper cable for this panel, and in order to try to test this thing out in the meantime, I took one of my other cables and rearranged some of the wires to get everything in the correct spot so that at least nothing's going to be damaged. And you can also see that the factory connector has the lock tabs on it, and this one does not. However, the physical connector itself is the same. And there's a lot less wires in the replacement cable, because mainly all the ground wires are all populated on this, and on this cable they're not. Again, I'm going to use this only temporarily for testing, and order the proper cable that's designed for this panel before I finish this project up. But I think I've got everything in the right spot that it should at least power the panel safely. There are some control wires in this harness for selecting the LVDS data format, and there's a test pin, a couple other things that need to be pulled either low or high depending on the application, and I'm not sure if this basic cable is going to work properly in that respect, but at least the power wires are in the right spot, so nothing's going to get burned out. But anyway, let me get this cable hooked up so I can set the plate back on here, and then we'll take a look at the power supply. Okay, looking at the power supply here, I've removed one of the cables to make it easier to see the connector. We've got two other connectors here. These are both outputs. One goes to each of the two inverter boards, and the pinouts are all labeled. And this, where it says A, B, and C, I think those are the control wires for the inverters, and they're essentially repeated in parallel on all three connectors. This connector here is the one that went to the main board, so this is the connector of interest. We have the power on signal on the last pin here that actually turns this power supply on. Some 12 volt pins, the ground pins, 5 volt standby, and then those three control lines. Can't really get a clear picture here on the camera because it's too close. There we go. And on the power supply here, it shows the ratings, and it also says that the power supply on signal is high active, meaning once we put a high level logic signal to that pin, it will turn this power supply on. On this particular TV, the on voltage is 3.3 volts, but I'm all but certain that the power supply can work with a 5 volt power on signal. So what I can do is use the 5 volt standby output, jump that to the power on pin, and it should turn this power supply on. Another important thing before you do that, though, is to remember that some switching power supplies need a minimum load on their output. This seems to be, you know, just has 12 volt output for the main board, which is what the new board also uses. Hopefully it's going to be enough to have this thing run properly. So I've had, I worked on a monitor earlier that I wasn't using some of the outputs, and the power supply kept oscillating and, you know, turning on and off and on and off, and I had to put a resistor on the unused output for it to run. But hopefully this one's going to be a little more simple. I'm glad to see that this TV used the same physical series of connector on its original main board that is used on the new board. These connectors are actually made by JST, which is Japan Solderless Terminals, and the series is called a PH. They have a 2mm pin spacing, and there's a larger variant of these that are common called the XH series, which looks almost identical but has a larger, I think it's a 2.5mm spacing, something like that. Since I don't have my spare pins and housings with me, I'm going to have to use the ones that came with this board and then take these wires out of this housing and move them over to the smaller housings that fit this particular board. So that's why I was glad to see that it was the same type of connector. I can just move the pins right over, don't have to splice anything. So I never ever like to splice wires and stuff like this. I like it to look factory when it's finished. Well, I'm making some progress here. I was glad that I double checked the pinout on this end as well, because I found that I would have grounded out my controller, because after moving around the wires on that end, I had to do the same for the power wires over here. They had one of the red wires on the ground instead of on the positive. So they don't always, I guess they don't always stick to the color code on that, but I got that straightened out. I traced back the wires to the connector to figure out exactly where they went, and like I suspected, the A, B, and C wires do go to the inverters. Only the B and C were used, which looks like the power on signal was B and the dimming was A. I only have the power on connected right now, and then I took one of the ground and one of the plus 12 and ran those back to the input of the new controller. In the finished project, I'm going to have each of those doubled up, but for now, one wire on each is fine. This controller doesn't use hardly any power. So at this point, I did do a quick power up, and when the board started up, I saw the blue lights come on the inverter for a few seconds until this thing said no signal and shut down. However, I did not have the LVDS connected at the time, because I was verifying the pinout. So at this stage, this will be the first time I've plugged it in with everything connected, and I really hope it's going to work. I'm not sure if I'm going to be able to plug this in with the screen facing upward though, because I can't get to it. I can try. Well, good news so far. I couldn't do the power up on camera because I needed like both hands to hold the thing up and plug in the cord, but I turned it on and saw the no signal notification come on the screen, so the odds are very good that everything's going to work as soon as I've got the VGA connector hooked up, because otherwise this thing just immediately goes in standby after saying no signal. So I'm going to find something to plug in to the VGA and give this thing the real test. Alright, got everything hooked up here. Unfortunately, the button board for controlling that is underneath at the moment, but I just want to see if this thing's going to power up and give me a proper picture. So I've got a little computer running down there, just sitting at the BIOS screen or wherever it's at, and I'll try to juice this thing up. If I can get to the power connector under here. Come on. Ooh. Sweet. Well, I wish I had something a little more colorful to put on the screen, but look at that. It's alive. I'm going to take a quick break and go get something to eat. I've been sitting down here all day, haven't ate anything, been so wrapped up in this, so I'll be back in just a little bit and give this a further test. Here we go. I propped it up against the cupboards here so I could get a good look at it. That computer down there should be running MemTest 86. I've got the stick for it plugged in the front anyway. So let's take a look at it. Power supply comes on immediately, and there we go. Looks like a monitor. I don't even have the dimming line for the inverter hooked up yet, so it's running probably about half brightness. Still don't look too bad. So I guess what's next is I'm going to properly mount those boards and tie up all the wiring and experiment with the brightness control for the inverter. Other than that, there ain't much left to do. I got what I wanted, which was a bare minimum VGA monitor that turns on as soon as it's plugged in. Perfect to be mounted inside a game cabinet, and being outside of the plastic case, it's going to run much cooler than it ever did as the original TV. So should last a while. And with how cheap those boards are, I don't care if they burn out after 2 years, because $6 or $7 I can get another one. In fact, I think I've got 3 or 4 of them on hand, so no worries on the board going bad for the most part. Now that I know this is working, I'm a little bit bored of looking at the MemTest 86 screen here. I want to find something a little more colorful and higher resolution, so I remembered I've got a compact computer sitting down here that I have never hooked up before. I got it from a coworker, and I'm pretty sure it's Windows XP. It's been sitting around for several years. I don't even know if it's going to start up. So while I've got this monitor sitting here and the VGA cable out in the open, might as well give it a try, just out of curiosity. Okay, this is a compact S5100NX. This is an older machine. 2.6 gigahertz Celeron, 256 megs of RAM, 80 gig hard drive, and a cute little pink heart sticker. Well, let's see if it's going to power up. I don't know if this thing works or not. Oh, yeah. Well, BIOS screen anyway. Battery must be dead. I haven't seen that loading screen in a while. It's freaking huge. I gotta back up a bit. I would love to do this with a 1080p display. I mean, I know that all newer TVs already have inputs that work with computers, but for some reason this is more fun to me. Boy, at the high resolution, that cheap driver board doesn't look so good, does it? Lots of noise in the picture. Well, computer's booted up anyway. Wonder why it was working good with that other computer, but not this one. Weird. Oh, it's looking good now. I think that control board just didn't like having a refresh rate higher than 60 Hertz. So once I set that and put the resolution on 1366 by 768, this thing looks as good as any old standalone computer monitor would look. Looks really good, actually. And if you were to buy an open frame monitor this big, it'd probably be over $1,000. So I think it's pretty cool to build one using a junk TV and a less than $10 eBay control board. Pretty sweet. So I'm looking forward to getting this all finished up and putting it to use. This is pretty much what the finished product is going to look like. I still have to mount the keypad. I plan on making a longer harness for this and putting it on the side of the frame somewhere, or wherever it's most convenient for the whatever cabinet it's mounted into. I've got the VGA connector back in its original position. I haven't put the rest of the screws in this cover yet because I'm not quite finished. I've also got to make a cover for the power supply because a couple of these heat sinks are live to the AC, and it doesn't feel very good when you have your arm across the chassis and the heatsink at the same time. That'll wake you up real quick. Other than that, everything's working great, working better than I hoped actually. And I didn't end up hooking up the dimmer connection for the inverter because even when I put that at 3.3 volts, it didn't really get any brighter. So I just left it open like it says in the data sheet. Let it run at its default value. So not much left to do with this. Just like I said, mount the keypad and put a cover on it, and it's ready to mount in the machine and be put to use. Oh, I don't know what's going to come next. I'd really like to do some more computer related stuff. It's been so long since I did any builds, and I've been looking at this case here that this compact is in and thinking about putting some new hardware in there, but to be honest, I really can't afford to buy any new computer hardware right now. Hopefully things are going to pick up though, and I'll be building stuff again soon because I really miss doing that. But working with monitors is another thing I really like to do, especially when it works out like this and can recycle old parts and make new stuff out of them. So I think I've missed quite a bit of information I wanted to cover on this. I might have to backtrack at the end of the video if I find anything I missed while I'm putting this together. It's been kind of a crazy day, and I lost track of what was going on. So if I find during the editing stage that I've missed anything important, I will follow up at the end of the video. But for now, I'm considering this project finished. I wanted to talk a bit more about these control boards, and since this was so hard to move around, I didn't want to use that as an example. So I grabbed another one out of my parts box. Not only are these universal in being able to run several different kinds of panels, but also with the connector and cabling options. There's a place to solder on a VGA connector directly, and also the barrel connector for the power input. Normally everything is on flex cables. See, like this one here, the barrel connector for the power is extended out with those wires there, and this ribbon cable is your VGA input. And then you've got the socket here that goes out to the keypad or button board, whatever they want to call it. This is just one example. There are several different configurations of these with more or less buttons on them depending on what your needs are. This particular keypad doesn't even use the last two pins on the connector. So basically you would pick an LVDS cable that matches your screen, and you would pick an inverter. You know, this is just one example here. This would run like a typical 17 or 19 inch panel that's got 4 lamps, and you know, you'd have 12 volts coming into this board at all times from the AC adapter, and turn it on with the keypad, and then this board would supply power to the inverter and the screen and run it all from a single power supply. And I had to do it differently with this application because that inverter required 24 volts where these can only supply 12 volts. So I used the existing power supply and configured that to turn on as soon as it's plugged in, and then that feeds the 24 volts to the inverters and the 12 volts to this. So basically the only thing that this is doing is running the voltage regulator and the signals for the panel. And then for the inverter output, I'm only using the on-off signal and the brightness control signal in that socket. So basically 3 wires, you know, the ground and the 2 control signals. So basically running it in reverse. If you were to take the keypad that's on the back of this and turn it off, it would turn off the control board, and you know, the picture would go out, but you'd still have the 12 volts and everything and the 24 volts coming off that power supply. Just the inverter would shut down because the control signal would be telling it to shut down. So that big power supply would basically be running all the time with no load on it, which really isn't ideal. But with the way this is going to be used, it's going to be turned on and off by the power cord with the rest of the machine that's mounted in. So it's not going to be sitting there just running when there's no signal in it. But yeah, I like these a lot. They got all the pins labeled on the connectors, and it's just generally nice to work with. And for the price, you really, it's a really nice deal. Another thing I wanted to mention about the backlight dimming control, I couldn't seem to get the dimming signal to work on these boards. It was always at 0 volts, and if I would turn on or turn off the economy mode or whatever it was on there, or the dynamic contrast ratio, then I'd get about 2 volts on that pin for the brightness signal. You know, and if I had no way to get that to work properly, I'm sure there's a way, but if not, and you want to drive the inverter to full output, you can get 3.3 volts by attaching the wire to the output of this regulator right here, which is putting out the 3.3 volts, and then that'll give you the full brightness level on the backlight inverter. But I'm pretty sure I can get the software on this board figured out and control it the proper way. When you adjust the brightness on the on-screen display, it actually adjusts like the brightness for the video signal, not the backlight. So yeah, anyway, I'm getting pretty tired and can't quite think straight, so I think I'm going to wrap this video up, and we'll see what comes next.